Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about rationalising surds. It's our second video on this topic. Now previously on Hegarty Maths, when we did multiplying surds inside brackets, we talked about the following. What surd could I multiply the following surds in brackets by to get a whole number? And I hope you remember saying that we would always multiply by its conjugate. So in this case 3 plus 2 root 2, in this case root 5 subtract root 3, and in this case 2 add root 3. Okay, because a conjugate of a number, say we have two numbers added together, a add b, the conjugate is always going to be a subtract b. And when I multiply those two together, I can work it out by doing the first number squared take away the second number squared. And that's actually called the difference of two squares, which we'll see in algebra. But that's what we used in the previous work. Now 3 squared here is 9. We're going to take away 2 root 2 all squared. 2 times 2 is 4, root 2 times root 2 is 2, 4 times 2 is 8, it will be 9 take away 8 is 1. Here we're going to get root 5 squared, which is 5, take away root 3 squared, which is 3, 5 take away 3 is 2, and the last one we're going to get 2 squared, which is 4, take away root 3 squared, which is 3, and we'll get the answer 1. So I need you to remember that here. If I gave you a surd here and asked you what do I need to multiply it by to get a nice whole number, I want you to think its conjugate. And previously in rationalising surds 1, we talked about how mathematicians do not like surds on the denominator of a fraction. So what they do is they think of what to multiply the denominator and numerator by to get rid of that root 3, in this case on the bottom. And they'd say I'm going to multiply top and bottom by root 3. On the top that gives me 5 root 3. On the bottom root 3 multiplied by root 3 is 3. I've got rid of that surd. I have rationalised the denominator. And what's this video about, do you think? This video is about rationalising surds obviously, but the surd on the bottom is ever so slightly more complicated. It has a genuine surd like root 3, but it's got a number added to it, or a number taken away from it. It's some sort of addition or subtraction on the denominator. What would we multiply the denominator by to make that a nice whole number? Well, hopefully you can see I would multiply it by its, that's right, conjugate, root 3 subtract 1. And I must do that to the top as well, root 3 subtract 1, based on what we've just talked about. Now the denominator is easy. Root 3 times root 3 is 3. Take away 1 times 1 is 1. 3 take away 1 is 2. And on the top, 5 times this, well, we could just expand out the bracket. That's going to be 5 root 3, and 5 multiplied by negative 1 is going to be negative 5. And that is the technique we're going to use throughout this video to rationalise these more complicated surds. Okay, so let's just do some examples. Rationalise the denominators of the following. I'm going to multiply the denominator therefore by root 5 take away 2, that's right. And on the top I must do the same, root 5 take away 2, because that's the conjugate of root 5 plus 2. When I do that, what do I get? Well, 1 times root 5 take away 2 on the top is just root 5 take away 2. And on the denominator, root 5 times root 5, well that's 5, and we're going to take away the answer to 2 times 2, which is 4. And tidying that up, 5 take away 4 is 1. Anything divided by 1 is just itself on top, so I'm going to just leave that as root 5 take away 2, and I'm done. What about this one? What should I multiply the top and bottom by? Well, hopefully you could see I'm going to multiply it by its conjugate, which is root 6 add 2. Let me just put brackets around there and brackets around there to remind us that we're multiplying by surds in brackets. And on top I'm going to multiply by root 6 add 2 as well. Now what do I get on top? 1 multiplied by that is clearly just root 6 add 2. No problem there. Root 6 times root 6 is 6. 2 times 2 is 4, so it's going to be take away 4. And we're going to get root 6 add 2 over 2. Now I can't simplify root 6, so I can leave my answer like that, and I'm done. Okay? Right, next two examples. Pause the video and try yourself. Okay, I'm going to just put a bracket there and a bracket there to remind me of that. So I'm going to multiply top and bottom by 3 take away 2 root 2 and 3 take away 2 root 2 in this case. 1 times that just gives me 3 take away 2 root 2. No complication on the top at all. Now on the bottom, 3 times 3 is 9. We're going to take away 2 root 2 times 2 root 2. 2 times 2 is 4. Root 2 times root 2 is 2. 4 times 2 is 8. So it's going to be 9 take away 8. Now 9 take away 8 is 1. So this divided by 1 is just 3 subtract 2 root 2. This one here, I'm going to multiply the top and bottom by 2 subtract root 5 and 2 subtract root 5. On the top, I therefore just get simply 2 subtract root 5. On the denominator, 2 times 2, well that's going to equal 4, and root 5 times root 5 is going to be 5, so 4 take away 5. So on the top, I still get 2 subtract root 5, and on the bottom, 4 take away 5 is negative 1. Now what I can do is I can do 2 divided by negative 1, which is going to be negative 2, and negative root 5 divided by negative root 1 is going to be positive root 5. And if I want to, I can write the positive number first, root 5, and I can swap it around, take away 2. Now that is just optional. You can write it like that, or you can leave it like that. But it's best to divide this by the negative 1 and this by the negative 1, because this is just sloppy. If you left your answer like that, it's just messy to have the negative 1 on the denominator. It's best to just have that as 1, so that you just have an overall answer, as it were. Okay, let's try another one. Simplify the following. What am I going to multiply the denominator by? Well, I'm going to multiply it by its conjugate, which is 7 plus 4 root 3. And what I do to the bottom, I must do to the top, 7 plus 4 root 3. Okay, so on the bottom, what am I going to get? Well, 7 times 7 is 49. 4 root 3 times 4 root 3. Let's think what we get. 4 times 4 is 16. I'm going to write the 16 down here. And root 3 times root 3 is 3. I'm going to write that down just to save me doing too many calculations in my head. So on the numerator, 2 root 3 multiplied by 7 is going to be 14 root 3. And 2 root 3 multiplied by 4 root 3, well, I'm just going to do that in 2 stages. 2 multiplied by 4 is 8, which I'm going to put into brackets. Root 3 multiplied by root 3 is 3, which I'm going to put into brackets. Again, don't want to do too much in my head and make a mistake. 14 root 3 therefore on the top, add 8 multiplied by 3 is 24, and on the denominator what have we got? Well, we've got 49 subtract 48, which is 1. So that gives us overall the answer 14 root 3 add 24, and we're done. Last one for us. Simplify the following. Pause the video, do try yourself. So I'm going to multiply the top and bottom by 2 root 3 add 4. Okay, let's think what we've got on the denominator. 2 root 3 times 2 root 3. So I'm not going to do that in my head. I'm just going to say 2 times 2 is 4. Root 3 times root 3 is 3. Take away the answer to 4 times 4, which is clearly 16. Then I've got to multiply out the top, which is 2 sets of brackets. So I'm not going to do that in one move. I'm just going to write root 3 take away 5, and then I'm going to write 2 root 3 add 4 and save that for the next line of working. Now on the denominator, I can work that out now. 4 multiplied by 3 is 12, and 12 take away 16 by the symmetry of subtraction is negative 4. So I've sorted that out. Now let's do the top using the distributive law. Okay, so what I've got to do here, root 3 times 2 root 3. Root 3 times root 3 is 3, multiplied by the 2 is 6. So I get 6 for that first term. Root 3 multiplied by positive 4 is positive 4 root 3. Sorted for the first term. Now here, remember it's negative 5. Negative 5 multiplied by 2 root 3 is negative 10 root 3. And negative 5 multiplied by positive 4 is negative 20. Let's do some tidying up now. We've got ourselves 6, and we're going to subtract 20, and we've got ourselves separately positive 4 root 3, and we're going to take away 10 root 3. So 6 subtract 20 by the symmetry of subtraction is going to be negative 14. 4 root 3 take away 10 root 3 is going to be negative 6 root 3. And all of that divided by negative 4. Now, can we divide the top and bottom by a common factor? Well, we certainly can divide it all by negative 2, can't we? So let's do that. Negative 14 divided by negative 2 is positive 7. Negative 6 root 3 divided by negative 2 is just going to be positive 3 root 3. And negative 4 divided by negative 2 is going to be positive 2. And we can't simplify that any further, and we're done. So that's it for this video. Thanks for watching.